let's look at another couple of things which have changed within the CPU. Now, I mentioned in a previous video that we now have 4 outputs from the control section into the ALU, which gives us an option of 2 to the power of 4, which is 16 values that we can choose within the ALU. So we've now got 16 functions that we can generate within the ALU. So if we have a look at the bottom here, you'll see that we have our 4 inputs coming in, and they're coming into a 4x16 decoder. So we've seen this type of 4x16 decoder before. We've built them in the previous course. So we're now going to have 16 control lines coming out, and each of these control lines will just go to a little buffer here, which will pass the little enable section, which will pass the value through to the output. Now, the first lot here I've kept really the same. So we've got our adder, we've got a shifter. Now, we did have a shift left and a shift right, but now we've got the shift left and right within the same block. And also I've adjusted it so that we can shift by a certain amount. The previous shift left and shift right, we could only shift it one left or one right at a time. But now we can actually put in a choice. So for example, if we wanted to shift it 3 to the left, we could use shift left #3 and then the register value. So it will shift the contents of the register 3 positions to the left or right, or 4 positions or 5. So it's a much more general shifter, and we'll talk through that in just in a moment. And this is really the main one we want to talk about here, but we'll quickly go through the rest of them that we've got here. So the other ones are much the same as actually we had before. We have the not, the and, the or, and also the exclusive or with the comparator. Now, the ones that we've added, and I've mentioned a couple of them previously, are the increment and decrement. So it adds 1 or subtracts 1 from the value. And again, we use this quite a lot, especially whenever we're doing the jump to subroutine or push or pop or any kind of stack, anything that involves a stack. So that's why I've added those 2 here. We've got a multiplication, a division. We've got another addition here, which we might not need, okay, but we're going to keep it for now. And if we don't need it, then it gives us a spare position for us to use somewhere else. We've got a subtractor here, and also at the very top, I've added in this extra AND gate with values of 0 coming in. So we're using this in order to clear off the contents of any of our registers. So if we have a register value coming in here, and if we AND it with all zeros, then the output will always be a value of 0. So it takes whatever comes in here and it just puts out all zeros here. So this is in effect now a clear function. So we've got CLR and say CLR R0, CLR R1, R2, R3. So we can clear off all the contents of a register, which is quite a handy thing to be able to do. So that's the basic setup here, and you can see there's nothing really changed in terms of the overall architecture. Now, the one that we're really interested in is the shift left and right. So I'll zoom in just a little bit so we can see this a bit better. Now, I still use the same input here. So the shift left and shift right were coming in from the pins 2 and 3. So that's pins 2 and 3, shift left, shift right. I took a copy, and the left and the right go into this shifter in order to choose whether we do a left shift or a right shift. And the 2 outputs go through an OR gate and still go through this choice. So this is really our little enable section, so that the two outputs go through this OR gate into the enable section for the left or the right shift. So that's pretty straightforward. There's not really any changes, many changes at this level. Now if we drop down into the shifter, I'll quickly talk through this. So let me adjust this so we can get it back on the screen properly. Okay, so this is our shifter here, and again we've got our choice here of our left and our right. So do we shift left, do we shift right? There's also a carry in for the shifter, and there's also a carry out for the shifter, and we have the actual shifted value here at the output. And then we have our actual input here, which is getting shifted, and we have our left or right shift count. So I'll just quickly show you it working, and then we'll have a quick talk through it. You can always go through it yourself at your leisure and put some values in and see how it's working. So let's see this working first of all, and then we'll have a little talk through it. You can see here that we don't have any choice of left or right, so we're not doing any shifting at the moment. So if we had an input in here, say a 1 there, it should pass it directly to the output here, and you can see it's doing that. So this whole thing just becomes transparent, and it passes this value straight to the output here, as you would expect. Now let's go now and we'll put a value of 1 in here, say in the least significant bit. Now if we're going to left shift, we click on this and it should shift it to the left. So if I put a value here of 1, it'll shift it to the left by 1, and you can see here it's taking this 1 and it's shifting it to the left, and I can shift it to the left by 2 and also 3, or you can shift it by a value of 4, and we can keep doing this all the way up to a value of 16. So we could shift it, if I made this 1, 2, 3, 4, you'll see that the value shifted from here all the way up to this point here. Now that's the left shift, so we can shift it as far as we want in that direction. Now we could do the same for a right shift. So we had the value here up at the most significant bit, and we were to shift it right, so I could click on the right shift, the value here up at the most significant bit, and I clicked on the right shift, and we want to shift this to the right. You can see that the output here is just transparent at the moment, and if I put a value of 1 in here, it'll shift it to the right by 1, and then by 2, and then by 3, and so on and so forth, all the way up to 16, so it can shift it all the way back down to this point here. So that's the simple left shift and right shift. Now there is also the option of having a carry in and a carry out. So if we were to look at the carry out first of all, if we were to shift it too far over, then we would end up shifting it out. So let's say we're in this position here. If I was to left shift it by 1, then it's going to shift it out, and we'll get a carry because we've went too far. So if I put this 1 on here, if I actually do a left shift, so if I do a left shift, and if I left shift that by 1, you can see here that this 1 here has dropped out, okay, and the carry has come on, so we've got a carry for this. Now the same thing would happen if we were to do the value on the right shift. So if we were in this position here and we shifted it to the right via a value of 1, you'll see that the output, it shifts away and disappears because we're shifting it to the right, and again the carry is going to come on, so that's a carry out. And we also have to take care of the possibility of actually having a carry in. So if the carry in was to go high here, then you can see here that we're going to have a carry in. So this is the carry in term here. If I just take this off, so this is a carry in. So at the moment there's no carry in, but if I did have a value of 1 here, you can see here it's actually going to pull this carry in. Okay, so that's it. That's the carry coming in, and it's getting shifted in from the left-hand side. Okay, and we can carry in here. So that tells us how many carries we're going, how far it's getting carried in. Okay, and again we're going to have a left and a right for this as well. Okay, so we can left shift the carry in, and we can right shift the carry in as well. Okay, so that covers pretty much the basics of how the circuit actually operates. And to actually get it working, what we're going to use is, rather than having a shifter, we're actually going to use two rotate left and a rotate right. So the rotate left would take the most significant bit, and if we were to shift the most significant bit out, then it would actually rotate and it would bring that back round and down into the input. Okay, so it's actually a rotation that this does. And again, so we've got a rotation left and a rotation right. But what I did was I made those 32 bits, so that if we were to rotate, in order to get the carry out, I made those 32 bits so that whenever we shifted left or right too far, then it would just shift left or right into the next 16 bits. And we take those next 16 bits out here, and those become our carry bits. Now the only thing to describe here now is the mux. You can see here the mux has got 4 inputs but 1 output. But the first 2 inputs are tied together, okay, and they're given a value of 0. Now this input here is going to give us the value of 8000, but of course this is actually in hex, so 8000 in this hex is actually going to be in binary, it's going to be 16 bits, and it will be the most significant bit of those 16 bits will have a value of 1. The other one in here is, of those 16 bits, the least significant bits will have a least significant bit will have a value of 1. So those are our choices here. Now, if we were to have, for example, a carry in, so we click the carry in. Now, whenever we're using a left or right shift, so whenever this value here actually, any of the first 5 bits of this go high, then we know we're doing a left or right shift. So in that case, either we'll have a choice of right or a choice of left. Okay, so we won't have it where there's a value in here and there's no value here. That won't happen, okay, because it's all part of the same command, the same instruction. So let's just choose one. So we can choose a value of a left. Okay, so we're doing a left shift and there's a carry in coming in. So let's say our value here is a value of 1. Okay, so whenever we left shift this by a value of 1, we're going to carry 1 in from the least significant bit. So if we then notice in the input, if that's 1 here, if we carry 1 in, we click on here, you can see that this is the carry in. So that value there has been carried in from the least significant bit because we're left shifting it. Now, if we were to do it round the other way round about, and we were to say work through and have a value here which is 1, which is in the most significant bit, and let's say we were going to right shift. So if we were to right shift this here, then it's going to pull in the carry in from the most significant bit. So if I click on, say, 1 here, then you can see here it's going to drag in the value for the most significant bit. So that's what the mux is here for. It's to allow us to drag in the carry in here and position it correctly. Now, an awkward little circuit to describe actually, but the best thing to do is have a little play about with it yourself and you'll see exactly how it's working. And it's quite useful because now we have a much more general shift command. Now that's all we really need to cover on our basic changes to some of our architecture. So thank you for listening. I'll get you on the next video. Goodbye.